Welcome back to statistics. Some of the calculations we've been doing require the use of a calculator of some sort. For instance, some of the square roots involved with standard errors, for instance. And some of the standard errors we've been looking at, the formulas get sort of increasingly involved as we've moved along. So I wanted to take a minute and just sort of show you how you can use your phone calculator, for instance, to do some of these computations. So let's take a look at a couple of problems we've seen recently and look at the calculations on a phone calculator. So here is a standard error calculation for a difference of two means. And you see the thing all worked out right there. I'm going to do that calculation basically just on an iPhone. If you have an Android phone, there's a calculator on that that's pretty similar. But hopefully this will be helpful in any case. I am going to just pull up my calculator on my screen here. It has exactly the same layout as the iPhone calculator, and so you know the the keystrokes will be exactly the same. So if we wanted to compute this standard error, it's a square root of a sum of two fractions. And in this case, you can kind of just work from inside out and do the calculation correctly. So for instance, to start, let me just make sure everything's cleared out. I'm going to clear my current display. I'm going to clear the memory, although I won't use the memory here. And let's just enter 24.397 squared divided by 10 plus 13.467 squared divided by 12, and then hit the equal signs. And that gives us the value under the square root, right? The 74.6347 rounded to four places. Of course, the advantage of doing this is that in doing the calculation, you don't have to round any of the intermediate steps, and that avoids round off error sort of building up during the calculations. Now all I need to do is take a square root. So I'll do that. And we get 8.6391377.8 and some change. Plenty of accuracy for whatever purpose we need here. Rounding that to four places would give me 8.6391, which is, of course, the right answer. So, and in this case, the formula for the standard error of a difference of sample means lends itself well because of the way the order of the operations and the precedence of the operations on the calculator. You can pretty much just enter that guy in as it appears from inside out, right? You do the square root last and get the right answer. Uh, let's take a look at a different sort of standard error. This one is a standard error for a difference of proportions. Um, we had the formula, the general formula back here somewhere. Uh, there it is. The standard error for a difference of proportions is again a sum of two fractions, but this time it's a little more intricate because you've got to multiply a sample proportion by its complement, right? One minus that sample proportion, then divide by the sample size, and then do the same thing for the second sample. Uh, Here, our sample proportions, P1 hat and P2 hat, were 5,823 over 10,000 for P1 hat, 3,125 over 8,000 for P2 hat. And I'm just going to kind of enter those in. That's exactly what these numbers are here. The point 5823 is our 5,823 over 10,000. The point 3906 is our 3,125 over 8,000. But to avoid round off error, what I'm going to actually do when I compute this guy is I'm just going to enter these fractions in uh, as I compute, rather than using the four places of accuracy I have here, which would be okay, but you're likely to build up some round off error because everything you've done has been round. If you just entered these numbers in as they appear, everything would be accurate to 4 places, and then you need an accuracy of more than that, right? Because the standard error turns out to have at least I'm showing 6 places here, so it's better just to enter in the fractions directly rather than the decimals here. So let me bring up my calculator and we'll do that. Again, you work from inside out, so I'm going to work on this first piece first. That's our so let me clear everything. That's my 5, 8, 2, 3 divided by 10,000. And then I need to multiply that by this difference. I do need the parentheses here. So I'll say parentheses 1 minus 5, 8, 2, 3 divided by 10,000. And close the parentheses. So that's the top, and then I divide that by 10,000. And let's just hit the equal signs. That's that first fraction there. It's a tiny number. Let's go ahead and store that into memory. So I'm going to hit the memory plus key here. Make sure your memory's cleared before you do that. And then just hit memory plus. So that stored that number in memory. Now let's compute the second fraction here. That would be, let's clear everything out here. 3, 1, 2, 5 divided by 8,000 times, again I need the parentheses, 1 minus 3, 1, 2, 5 divided by 8,000. And then close the parentheses and then divide all that by 8,000. So equals, that's the value of this second fraction. Again, it's a really tiny number, but we want to add that to our first fraction. The first fraction is stored in memory. If I just add this value to my memory, hitting the memory plus key again, so bang, then if I recall my memory, what's in it is the sum of those two fractions. And now I just need to take the square root of all of that. So I'll do that here, bang. And that gives me my 0.007353727 and some change, which again is all the accuracy I would ever need for a practical problem. And rounding that to 4 significant places, and that just means round after ignoring leading zeros, we'd get 0.007354, right? And so there are other ways that you can, carry out these calculations, but those are some of the easiest ones. So I hope this has been helpful. If you need some more help with your calculator or with anything else involved with the course, please let me know. And we'll be talking at you again real soon. Y'all take care.